Hi, I'm Adam from forgottenclank.studios, and I'm here to showcase the Forgotten Convolver. This is a custom filtering device incorporating two modules, a digital and an analog module. I'm going to talk about the digital module first. Up here, I've prepared a drum loop. Let's listen to the clean signal first. Now with the filtering, at the bottom of the device, you can see the frequency response that's being applied to the input signal. And at the top, you can see the impulse response. This is where the magic happens. If you'd like to know more about how this device works under the hood, I'd like to refer you to the product manual on the shops page. Let's draw in another impulse response. As you can see, we have a huge boost in the lows down here, and that can happen a lot if you're not using the fade out button. The fade out button fades out the impulse response and most of the time smooths out the frequency response. You've also heard a bit of limiting going on, and that's because of the limiter on my master bus. The shift knob changes the amplitude of the individual samples. When turned to the right, the sample points are moved towards the center, and when turned to the left, the sample points are moved towards the top. I think it's great to use this shift knob with automation, so let's do just that. I'm going to draw in an automation clip. With this, you can also get some movement into your sound. The knobs on the right are a basic output stage, so dry, wet, and gain. The knob on the very left determines the length of the impulse response. You can go up to 64 samples and down to 4 samples. Fewer samples give a more smooth frequency response, while more samples give you more control over the frequency response. What I like to do is to draw in a 64 sample length impulse response and then reduce the length. As you can see, these are all very different frequency responses. The thing about impulse responses is that they are connected in a very complicated manner to the frequency response. So by changing just one sample, the frequency response is altered drastically. I like to use the Forgotten Convolver when sound designing. When I'm stuck doing sound design or just want to take the sound in a completely different direction, I can pop in this device, draw in some impulse responses and pick something I like. This is it for the digital module. Let's move on to the analog module by dropping in another patch. While the digital module implements digital FIR filters, the analog module implements analog type IIR filters. I'm not going to go into how this works exactly. If you're interested, read the section about the analog module in the product manual. For the moment, just know that the way these elements are positioned on the half circle and the type of element they are affects the frequency response. To the right, you have a few modulation parameters. First, there's the logify knob, which changes the frequency response in a very specific manner. Next, there's smart gain. With smart gain turned off, the filter will try to never boost any frequencies and only cut. As you can see, this can lead to huge cuts across the frequency spectrum for a lot of filters. With smart gain turned on, the filter will try to make a more informed decision on what the filter's gain should be. Similar to the digital module, the analog module's shift knob moves the elements around. For the demonstration, let's drop in another patch. At the bottom you have the usual output stage, so dry, wet, and gain. One thing worth mentioning is the effect of the dry-wet knob on the signal. One quirk of these elements is that they also change the phase response for the most part. When mixing in some of the dry signal, these phase shifts will also alter the frequency response through phase cancellation. Unfortunately, the changes in the frequency response caused by the phase shifts is very complicated to calculate, so it's not taken into account in the frequency display at the bottom. These phase shifts are not necessarily bad though. In fact, one type of element, the all-pass pole element, completely relies on these phase shifts to make changes in the frequency response. Let's drop in another patch to demonstrate that. All-pass pole filters are used in phases to create the phasing effect. Now you have much more control over how the phasing effect sounds. This is it for the analog module. You can also use the two modules in series by enabling them at the top. At the back of the device, you have some CV inputs for certain parameters. Finally, there's one thing I'd like to show you, and that's the linear phase low-pass filter patch. If you use a linear phase EQ or a multi-band compressor with linear phase options, this is the impulse response they probably use. In the frequency response, you can see that it rolls off very steeply, right about 10K. Then it goes up again, and I'd like you to ignore this part, as it happens with all linear phase low-pass filters. I wanted to show you this to demonstrate that you can also build rather complicated filters if you really dig into the details. That's it. If you have any questions, you can leave them down in the comments below this video. Alternatively, you can also contact me on Facebook or on my email address, which is forgottenclank.studios@gmail.com. There you can also report bugs, request features, request whole new rec extensions, or just say hello if you want to. Thanks for watching.